Let's look at the rest of our reactions. We have the hydrolysis of esters. So sodium hydroxide will break it right at the oxygen. We're going to remake a carboxylic acid and remake an alcohol. So it's the reverse of your condensation. So here you would have the sodium plus ion attracted to this oxygen negative ion. If we have an acidic solution or an abundance of hydrogen ions, we can go right away back to that carboxylic acid. That's the only case that we're going to look at this year. We also kick off the alcohol, so it takes that hydrogen there. So here from methyl propanoate, we remade propanoic acid and methanol. Let's look at amines. If we have a alkyl halide and ammonia, we're going to make a primary amine. Okay, so we're going to take one of the iodines and one of the hydrogens. We're going to make hydrogen iodide and ethanamine. If we have already a carbon chain on our amine, we have here a primary amine. We can add on another carbon chain, another alkyl group, by taking that iodine and one of the hydrogens and making now a secondary amine. If we have a secondary amine, we can take one more hydrogen to make a tertiary amine here. And you should review all the ways to name amines. We could also have a condensation reaction. So if I used ammonia, I would produce this amide here, methanamide. If I used a primary amine here, and I took a hydrogen and a hydroxide, I would kick off water always and make this amide here. So N-ethyl methanamide. If I have a secondary amine, I'm going to make this amide here. So I have my water that I'm making. I'm going to put 1, 2. It's going to stay on that nitrogen. 1, 2 stays here. In this last one, we're going to hydrolyze. So we're going to break apart any amide that we have, and it's going to break right here. We're going to remake a carboxylic acid and an amine. Okay, so if I have this one here, N-diethyl methanamide, I'm going to make back methanoic acid and N-ethyl ethanamide.